Okay, so this is our iPad project, Intro to Integration, by Rachel Chandler, Andre Castillo, and Joanna Sean. For our project, me and Andre went in my car and we decided to take our odometer readings and our velocity readings. Our starting odometer reading read 132,574.1 miles, and we also took it as we ended our trip, 132,581.4 miles. We calculated this difference to be 7.3 miles. We decided to transfer that into feet to help us with our calculations, and that turned out to be 38,544. So for our velocity readings, we decided to drive around for 20 minutes straight. So we have 0 through 20 in our minute intervals, and then we took our miles per hour at each interval, which was 30, 00, 32, 47, 43, 28, 0, 43, 00, 38, 33, 40, 0, 13, 00, 27, 26, 15, and 14. These represent what our speed at that point in time was during our car ride. Then from there we did simple math to turn the miles per hour into feet per minute. So this is our velocity versus time graph. We have our velocity in feet per minute, and we have our time in as minutes as we moved along in our journey. And this graph represents the basic plots of what our velocities were at each point, which would be at each minute, 1 through 20 minutes. Second drawing done by Andre is a representation of our right-hand sums. We use the right-hand points to create these brown boxes, and the orange lines represent the original function. Okay, so this next graph, also done by Andre, is a representation of our left-hand sums. Same exact thing as the right, except that we use our left-hand points for this one. This one is also going to be starting at f of 0, and then it only goes to f of 19. A little different from what the right-hand sums were, which started at the f of 1, and then went all the way to f of 20. So we did our calculations using our left and right-hand sums. To find our left-hand sum, we used our n value, which is 1, because we are only going 1 minute at a time, and that's how we set up our periods or our intervals, whatever you prefer. For our left-hand sums, we start with f sub 0 because we are going from left to right, not right to left. In our right-hand sums, we go from our right to left, so we start with f of 1. Now back to our left-hand sums. So we basically calculate 0 through 19, f of 0 through 19, and we use our velocities at each point, and we come up with 33176 feet. This is going to be a higher number than our right-hand sum. To find our right-hand sum, we do the exact same thing, except, like I said, we start with f of 1. We do this because we are going from right to left. We do so we multiply it by our n value, which is 1 in this case because of our period, and we go f of 1 all the way through f of 20. Exact same thing. These represent our velocities at each point in time on our period, and we're going to come up with 31768 feet. These measurements are a little off. Andre and I thought it was because of the way our car moves and the velocity at every single interval. It probably just meant that we were going a really short distance at that time and then stopped, which means our velocity would be 0. So like, for example, at f of 2, f of 9, f of 10, f of 15, and 16, just a little human error we noted. The answer to number 7, it talks about the significance of the area under the graph. When we are finding our left and right hand sums, we are trying to find a more approximate measure of what our area under the curve is. In this case, with our car problem, it's the net distance traveled during our trip. At least that's what I think. The area traveled would be what the area under the curve is. And this curve is represented by our velocity and our time. So the answer would be that the area under the graph it allows us to find the net distance traveled during our trip. And the answer to number 8, like I said before in my first video, is 38544 feet, and that is due to our odometer readings from start to end, and then we found the difference, which is 38544 feet. Okay, so as a kind of result slash conclusion, we discussed that our left-hand sum and our right-hand sum are significant of a upper or under estimate. In this case, our right-hand sum is going to be our underestimate because it obviously is a lower value, and our left-hand sum is going to be our upper estimate or our overestimate. Now, in class, we talk about how these two kind of represent where our absolute area under the curve, it kind of represents that our area under the curve is going to be in between these two values. Now, in relation to our odometer readings represent how far our car traveled in a certain amount of time. We found that to be a pretty high number, 38,544. Our left-hand sum is only 33,176, and our right-hand sum is even lower than that, 31,768. Now, at first going into this assignment, I thought that our odometer reading was going to be in between these two values. I don't know why it isn't, but when we're integrating something or we're finding the area under the curve, it's significant of our net distance traveled. So that's why these two values are so significant. But like I said, it's our net area traveled. This is our total distance traveled during our trip, our odometer reading, but these two represent kind of like a approximation of our values of the distance traveled during our trip.